In a laboratory at the University of Manchester, two scientists did something apparently simple. They removed layers of graphite using adhesive tape. What they didn't imagine was that they were about to discover a material that would revolutionize practically every field of modern technology. In 2004, Andrei Geim and Konstantin Novoselov isolated for the first time a substance that had been theorized for decades, graphene. This discovery was so important that just 6 years later, the two were awarded the Nobel Prize in Physics. But what exactly is graphene, and why is it considered by many experts to be the material of the future? In this video, we'll explore not only what graphene is, but also how it's changing entire industries, from electronics to medicine. Let's understand why, despite being essentially a form of carbon, one of the most common elements on Earth, graphene has properties that seem almost supernatural. And most importantly, how it will affect our lives in the coming years. To understand graphene, we need to start with something very familiar: graphite. Yes, that same dark material used in pencils. Graphite is made up of layers and layers of carbon atoms arranged in hexagonal patterns, like a honeycomb. These layers are loosely bonded together, which allows them to slide over each other easily. This is why graphite is so good for writing, as the layers peel off and stay on the paper. Graphene is simply a single layer of this graphite. It is a two-dimensional sheet of carbon atoms, just one atom thick. To get an idea of how thin this is, if we could compare graphene to a sheet of paper, the sheet of paper would be like a mountain next to it. 1,000,000 stacked layers of graphene would be just 1 millimeter thick. This ultra-fine structure and the hexagonal arrangement of carbon atoms give graphene extraordinary properties. It's as if nature created a perfect material and kept it hidden within ordinary graphite, waiting for someone to discover it. When scientists began studying graphene, they were stunned by what they found. This seemingly simple material had characteristics that challenged what we knew about material science. Let's get to know some of these properties that make graphene a true material of the future. Number 1. Graphene is incredibly strong. It is about 200 times stronger than steel, even though it is thousands of times lighter. A graphene sheet the size of a football field would weigh less than a gram, but could support the weight of a cat without breaking. This combination of lightness and strength is practically unheard of in the world of materials. Number 2. Graphene is an excellent conductor of electricity, much better than copper, which is the material traditionally used in electrical wires. Electrons can move through graphene with virtually no resistance, meaning it can carry electrical current with extraordinary efficiency. This makes it perfect for electronic applications. Number 3. In addition to conducting electricity, graphene is also an exceptional thermal conductor. It dissipates heat better than any other known material, which is crucial for electronic components that tend to heat up during use. Number 4. Despite being just one atom thick, graphene is practically impermeable. Not even the smallest gas atoms, such as helium, can pass through it. At the same time, it is completely transparent, letting 97.7% of visible light through. These properties would be impressive on their own, but what really makes graphene a revolutionary material is the combination of all of them in a single substance. It is no exaggeration to say that few discoveries in the history of materials have the potential to impact so many different areas. The potential of graphene is so vast that it would be impossible to list all of its possible applications. However, some areas are already seeing significant advances thanks to this material, while others are likely to be revolutionized in the coming years. Let's explore some of these fields. The electronics industry is perhaps the most eager to incorporate graphene into its products. The material's exceptional conductive properties could lead to chips that are much faster and more efficient than current silicon-based chips. Number 1. Graphene transistors. Researchers have already demonstrated graphene transistors that operate at frequencies hundreds of times higher than conventional silicon transistors. This could result in dramatically faster computers. Number 2. Flexible screens. Graphene is transparent and conductive, making it perfect for touchscreens. As it is also flexible, it can enable the creation of foldable or even rollable devices. Think of a smartphone that can be folded like a piece of paper. Graphene's strength and lightness make it an ideal additive to improve the properties of other materials. Number 1. Graphene-reinforced concrete. Adding small amounts of graphene to concrete can increase its strength by up to 30%, resulting in safer, more durable structures that require less material for the same function. Number 2, ultra-resistant polymers. Plastics with incorporated graphene can be stronger, lighter, and more heat-resistant, with applications ranging from aerospace to sports equipment. Number 3, conductive inks. Inks containing graphene can be applied to surfaces to create efficient electrical circuits, sensors, or even heating systems. Graphene also has an important role to play in the transition to sustainable energy sources. Number 1, solar cells. Graphene can increase the efficiency of solar panels, making them more competitive compared to fossil fuels. Furthermore, graphene-based solar cells could be lighter, more flexible, and more durable. Number 2, hydrogen storage. Graphene has the potential to store hydrogen safely and efficiently, facilitating its use as a clean fuel for vehicles and other applications. Number 3, supercapacitors. Graphene-based energy storage devices can charge much faster than conventional batteries and withstand millions of charge and discharge cycles without significant degradation. One of the most promising and potentially transformative applications of graphene is in the area of water treatment. Number 1, desalination membranes. Graphene filters with precisely controlled pores can remove salt from seawater with much less energy than current methods, potentially solving water scarcity problems in many regions of the world. Number 2, contaminant removal. Graphene can be engineered to attract and capture specific pollutants in water, from heavy metals to microplastics and pharmaceuticals. With so many extraordinary properties and potential applications, you may be wondering, why don't we see graphene products in every store? Why hasn't this revolutionary stuff completely transformed our lives yet? There are several significant obstacles. Number 1, production at scale. Although we have methods to produce graphene, manufacturing it in large quantities with high quality and at a reasonable cost remains a challenge. Very high-quality graphene is still extremely expensive. Number 2, integration with existing technologies. Incorporating graphene into established manufacturing processes can require significant changes in equipment and methods, representing a substantial investment for industries. Number 3, safety and regulatory concerns. Like any nanomaterial, there are concerns about graphene's potential impacts on health and the environment. Thorough toxicity studies and appropriate regulations are needed before widespread adoption. Number 4, intellectual property. There is a real patent race related to graphene, with companies and institutions trying to secure rights over production methods and applications. This can complicate business development. Despite these challenges, progress continues apace. Many experts believe that we are just a few years away from seeing graphene products becoming common in many areas, starting with niche applications where its unique properties justify the current cost. It is rare in the history of science and technology that a single material has the potential to transform so many different aspects of our everyday lives. Graphene, with its almost miraculous properties, represents one of these rare discoveries. While there are still significant challenges to be overcome before graphene can fulfill its full potential, progress has been steady and impressive. The question is no longer whether graphene will revolutionize industries and technologies, but when and how. In the coming years, we will likely see the first graphene-containing consumer products become commonplace. Batteries that charge in minutes, flexible smartphones, smart fabrics, ultra-precise medical sensors, and lighter, stronger construction materials. And that's just the beginning. Graphene is not just another interesting material. It is an entire technological platform, comparable in its transformative potential to electricity or semiconductors. We are just beginning to explore what is possible in this new world, where materials can be engineered at the atomic level. If this video made you better understand how graphene can transform our future, sign up now, because here we always go beyond the surface, exploring the technologies that are shaping the world of tomorrow.